Today we're going to talk about operations with radicals. By the end of this video, you should be able to perform operations with radicals and be able to simplify radical expressions. First, we're going to take a look at adding and subtracting roots. The thing you have to remember here is that to be able to add or subtract two radicals, they have to have both the same index and the same radicand. We call these like radicals. So what that means for us is that sometimes you have to simplify the radicals before you can add or subtract them. In this first example, we have square root of 27 minus 2 square root of 3. So we need to start by simplifying square root of 27. We need to find a perfect square that is a factor of 27. And 9 times 3 gives us 27. So I'm going to use 9 and 3 to simplify the square root of 27. The square root of 9 is 3. And square root of 3 cannot be simplified. So the square root of 27 simplifies to 3 square root of 3. Then I can bring down the minus 2 square root of 3. When I subtract these, I just subtract the coefficients. So I have 3 minus 2, which gives me 1 square root of 3, or just square root of 3. You can check these answers on your calculator. If you type the original expression in, square root of 27 minus 2 square root of 3, it gives you a decimal. We got square root of 3 as our final answer, so we can type square root of 3 in. And since it gives us the same decimal, we know that they are equivalent. The only tricky part with this is you don't necessarily know if your final answer is fully simplified, but you can use this to help see if you've made a mistake anywhere. Let's look at the next example. We have cube root of 24 plus 6 cube root of 24. Now, we should always simplify. We can either simplify this cube root of 24s now, or we can add them together and simplify it later. That's personal preference. I'm going to go ahead and add them together. So I have 1 plus 6, which is 7 cube root of 24. Then I need to find a perfect cube that's a factor of 24. You can refer to your power sheet. 8 times 3 is 24, and 8 is a perfect cube. So I can split cube root of 24 up into cube root of 8, cube root of 3. I know that the cube root of 8 is 2, and the cube root of 3 cannot be simplified. Then you've got to remember to bring down the 7. And the final step is to multiply 7 and 2, and you end up with 14 cube root of 3 as your final answer. The last one here has cube root of 12 plus 6 times the fourth root of 12. There's no way to change the index on these. So since one of them is a cube root and one of them is a fourth root, we cannot add them together, even though they have the same radicand. But if you can simplify cube root of 12 and fourth root of 12, you should do that. But in this case, you cannot. So that is our final answer. The next thing we're going to look at is the quotient property. This helps us when we are dividing radicals. The quotient property says that if you have the nth root, so that means any root of a divided by b, or any root of a fraction, that's the same as the nth root of a divided by the nth root of b, as long as b does not equal 0. So we can use this to help us simplify some problems. Here we have the fourth root of 80 divided by the fourth root of 5. I can rewrite this as 1 radical, fourth root of 80 divided by 5, and 80 divided by 5 is 16. The fourth root of 16, if you look at your power sheet, we're looking at to the fourth power row since we're looking at the fourth root. 16 is there, so the fourth root of 16 is 2. And again, you can use your calculator to help check your answer. If you're trying to type in cube root or fourth root, fifth root, a higher root, you can go to math, and then number 5 will let you type in a different index. So if I have the fourth root of 80, and then I can hit the fraction button, the fourth root of 5, I get 2 as my answer. So we know that for square roots, if you have the square root of a times the square root of b, that's the same thing as the square root of a times b. For example, the square root of 3 times the square root of 5 is the square root of 15. We can generalize this for any root. So the product property says that if you have the nth root of a times the nth root of b, that equals the nth root of a times b. So whenever multiplication problems here, you can simplify the radicals first, then multiply, then you might have to simplify again, or you can multiply first and have to simplify larger numbers. Again, it's partly personal preference. I'm going to go ahead and multiply first. So here I have negative 3 times the square root of 12. I'm going to go ahead and simplify first. So I have negative 3 square root of 12 times 2 square root of 18. So if I simplify square root of 12, I'm going to use square root of 4 and square root of 3. Square root of 4 is 2. Square root of 3 cannot be simplified. Then I need to remember to bring down the negative 3. So when I simplify negative 3 square root of 12, I end up with negative 6 square root of 3. When I simplify square root of 18, I'm going to use 9 and 2 because 9 is a perfect square. Square root of 9 is 3. Then I need to remember to bring down the 2 that was out front. So 2 square root of 18 simplifies to 6 square root of 2. Now, I need to multiply these two together. So I multiply the coefficients, which gives me negative 36, and then I multiply the radicands and end up with negative 36 square root of 6 as my final answer. For this next problem, we have both numbers and variables. And I'm going to go ahead and multiply them together first. And the reason I'm doing that is because it's a fifth root. The fifth root of 16 cannot be simplified. The fifth root of 4 cannot be simplified. So I'm going to have to multiply them together to be able to possibly simplify those numbers. So if I multiply this together, I end up with fifth root of 64, x to the 10th, y to the 8th, z to the 11th. Hopefully you remember from the last video that we need to look at the fifth root of 64, the fifth root of x to the 10th, the fifth root of y to the 8th, and the fifth root of z to the 11th separately. So when we're looking at the fifth root of 64, let's go to our power sheet. We're looking at to the fifth power row, and I know that 32 times 2 will give me 64. So that's what I'm going to use to help simplify this fifth root. So the fifth root of 64 can be split up into the fifth root of 32 times the fifth root of 2, which gives me 2 fifth root of 2. So I'm going to space this out so I have plenty of room to write my variables in there as well. Now remember that when you simplify radicals with variables, you need to think about doing division with remainders like you did in elementary school. So if I have the fifth root of x to the 10th, 10 divided by 5 is 2 with none left over. So I'm going to have an x squared outside the radical and no x's inside the radical. When I do the fifth root of y to the 8th, I'm going to do 8 divided by 5, which is 1, and 3 left over. So I have 1y outside the radical and y cubed inside the radical. Lastly, when I do fifth root of z to the 11th, I do 11 divided by 5, which is 2, remainder 1. So I have a z squared outside the radical and 1z inside the radical. So this will be my final answer. The last type of problem we're going to look at is when we multiply binomials. It's going to be just like we multiplied binomials in the last few units. We're going to double distribute. So first we need to do 1 times 3, which is 3. Then 1 times negative square root of 10, which is just negative square root of 10. Then we multiply square root of 5 times 3, which is 3 square root of 5. Then square root of 5 times negative square root of 10, which is negative square root of 50. Now we need to simplify all of the radicals and see if we can combine any of them. Square root of 10 cannot be simplified, square root of 5 cannot be simplified, but square root of 50 can. 50 is 25 times 2, so the square root of 50 can be simplified to 5 square root of 2. So if I write out my final answer, I have 3 minus square root of 10 plus 3 square root of 5 minus 5 square root of 2. I cannot combine any of these terms because even though they're all square roots, they have different radicands. For this next example, we're going to do the same thing. 2 times 3 is 6. 2 times negative 2 cube root of 9 is negative 4 cube root of 9. Negative 3 cube root of 3 times 3 is negative 9 cube root of 3. And negative 3 cube root of 3 times negative 2 cube root of 9 gives me positive 6 cube root of 27. So again, we need to see if we can simplify any of the radicals. Cube root of 9 cannot be simplified, cube root of 3 cannot be simplified, but cube root of 27 can. If we look at our power sheet, 3 cubed gives you 27, so the cube root of 27 is 3. So this can be simplified to 6 times 3, which is 18. So when we go to combine our like terms, all we can do is add the 6 and the 18. We end up with 24 minus 4 cube root of 9 minus 9 cube root of 3.